Hi, welcome to DappBlocks. In this video, we will learn how to deploy Solidity smart contract on Ethereum blockchain using ethers.js. If you are new on the channel, my name is Himmat. Here we learn all fundamental concepts and practical development of blockchain technologies. So if this is something helpful to you, then press the like button and subscribe to the channel. Let's get started. So first we need to install the Solidity compiler. So npm install -g and solc. Already installed it in previous video, but still I am installing for you. So to check the solid compiler, just type solc-js version. So this will provide us the which version we have installed. So 0.8.15 this is the version of the solid compiler we have installed. So this is our package.json. We have this ethers. So we need to install this library solid dependencies. So npm install. So this will install all the dependencies for this project. Now let's create one folder, that is contracts. So here we can write all your contracts. Create a file, that is storage dot. So this is the solidity file, and as we have seen in the last videos, this is the storage solidity file. Here we have the compiler as well as deploy. So we can compile and deploy from here as well by selecting the environment and all the details. But now we are using the solidity command line and the ethers.js. So just copy that and paste it here. So this is our the smart contract. Now we need the ABI and the bytecode for the smart contract to deploy. So let's create a folder build. So in that we're going to create the ABI and bytecode file. You can copy this from here as well, but we're going to use the command line to generate those files. So here in the command line you can write the code or write the command. So first go to the contract and write a command solec, then -bin is to generate a bytecode and the file name at the storage.ss. So this is the smart contract file name, and we are generating the output in the build. So that is not, so this should be solc-js. So this will generate our bytecode file in the build folder. So if you see there, this file got created. So this is the bytecode object. So now we need the ABI. So instead of build, just change it to ABI. This will generate the ABI file. So if you see the compilation detail, bytecode, this objects got created in the first command, and then the ABI, this ABI. So ABI in the JSON format, just check that ABI. So this is the ABI for this smart contract. So we need to create a file, deploy file for the deployment. So deploy.js. Here we need the ABI and the bytecode. So we need to read those files. So just create constant fs equal to required for fs file system. Okay, then let's read from files. Okay, then constant ABI equal to fs dot read file sync, then path of that file. Just go to the folder contract build So right click on the API and copy relative path, just paste that part so here in double quote and change the slash backward slash backward slash. Okay, and this is JSON, so we need to convert that to the JSON. So JSON dot pass. Okay, yeah, let's try and print this console.log API. Okay, so save this file and node deploy.js. Okay, this is our API. So we need the bytecode as well. So constant bytecode equal to fs dot read files, saying the path of the bytecode or the bin file. Just right click, copy relative path and then paste it here. And this is the object, so we need to convert that to the toString. So just change this slash and dot toString. So now we have the API and the bytecode with us. Now we need to connect to the blockchain using the ethers.js. Connect to the blockchain. Okay, so we have the ganache constant provider equal to new ethers. So this ether library got already imported. Okay, ethers dot get default provider, and then you need to pass the blockchain URL or the RPC URL. So for the ganache you can find this RPC server, just copy this URL, okay, paste it, and for the mainnet and testnet you can get it from the infura.io. Mainnet and testnet get from infura.io. Okay, then we need the private key constant, that should be in hex, so hex private key, change this, okay, equal to new buffer dot from in bracket we need to pass the private key. So here, so since this is the ganache local blockchain, so I am showing the private key for this particular wallet. So for your wallets or the mainnet and testnet, you should not provide the private key as a hard coded over here. You can either use the .env or other way to provide the private key. You should not disclose your private key to anyone else. Then we need the signer, so const signer, so this is to sign a transaction. So sign the transaction, new ethers dot wallet, and then we need to provide parameters, that is hex private key and the provider. So now we have the provider and the signer with us. Okay, create a function, async function deploy, just call this function deploy. Okay, this is a function deploy to deploy the smart contract on the blockchain. Okay, then we need the factory, the contract factory constant factory equal to new ethers dot contract factory, and here you need to pass the parameters, that is ABI Then we need the bytecode and the signer. Then we need to deploy it. The set of the deploy, that is constant deploy of the contract equal to await factory dot deploy, and then we need to send a deploy transaction. So constant then deploy contract equal to await and then contract dot deployed. So this will send a transaction to the blockchain deployed. This will send the transaction, wait for the deployment, wait till the deployment, send transaction deploy contract till deployment. Okay, and just print the contract address, deployed contract address once deployed, that console.log deploy contract is deployed contract address into deployed contract dot, so it should be deploy contract dot address. Okay, so you just save this file. Okay, and you can change the from here also you can compile and deploy it. Save this file and run a command node deploy.js. So this should deploy. So this is the deployed contract address. Just verify it. So this contract address ending with 030, and first block got added, that is contract deployment, and there is transaction count is 1 for the first account. Transaction is there, blocks got added. Okay, now you can copy this and go to the here in deploy, select the environment which is the ganache provider. Here you need to change the JSON RPC, so copy this and go here and paste it here and save for okay. And this is connected to the ganache. Then just copy the deployed address, contact address, and enter it here and click on add address. So you can access all the functions from the deployed address or deploy contract. There are two functions, store and retrieve. Just go to the contract, storage.solidity. If you see there is the store and the retrieve. These two functions are there, so it is showing the same. So you can store some value, so let's say 50, so that is stored in the blockchain. So you can find the details. So this second block got added, that is the contract call from a wallet or from address, from address. Let's try to change the account and store another value 70. See, so this way we can access the smart contract from multiple accounts. Since see, this is the contract call from this address, you can check the transaction count of the second wallet, that is 1, and this block got added, new block gets added. So this is how you can deploy your smart contract using the ethers.js, and you can access the smart contract either using the remix, or you can write your own front-end code and access the smart contract. So in upcoming videos we'll start learning the solidity functions, Thank you for watching the video. Please like and subscribe to the channel, and I will see you in the next video.